Parallel lines, proving them with converse theorems. Have you ever wondered how we can prove that two lines are parallel? Today, we will look at the fascinating world of parallel lines and how converse theorems help us with this proof. When a transversal intersects two lines, it creates angles that can tell us a lot about those lines. A transversal is simply a line that crosses two or more lines at different points. Let's start with the first theorem. The converse of the corresponding angles theorem states that if two lines cut by a transversal create congruent corresponding angles, then those lines are parallel. Corresponding angles are pairs that sit on the same side of the transversal and in matching positions relative to the two lines. For example, if angle A on one line equals angle B on the other line, then we can confidently say those lines are parallel. Next, we have the converse of the alternate interior angles theorem. This theorem tells us that if two lines cut by a transversal from congruent alternate interior angles, then the lines must be parallel. Alternate interior angles are located between the two lines but on opposite sides of the transversal. Now, let's talk about the converse of the alternate exterior angles theorem. If two lines cut by a transversal create congruent alternate exterior angles, then those lines are parallel as well. Alternate exterior angles are found outside the two lines on opposite sides of the transversal. Lastly, we have the converse of the same side interior angles theorem, also known as consecutive interior angles. If two lines cut by a transversal from supplementary same side interior angles, meaning their measures add up to 180 degrees, then the lines are parallel. To prove these theorems, we often show that if the angle relationships hold true, then the lines must be parallel. One common method is to construct congruent triangles using auxiliary lines and apply properties like vertical angles and the transitive property of equality. Understanding these converse theorems is essential in geometry. They allow us to confirm parallelism by looking at angle relationships rather than measuring the lines directly. This approach is often simpler and more practical. These concepts have real-world applications too. In design and construction, ensuring structural elements are parallel is vital. For example, measuring angles with a transversal can help confirm that beams and walls are aligned correctly. In navigation and mapping, angle measurements can help verify parallel routes or boundaries. By mastering these converse theorems, you can confidently prove when lines are parallel. This skill is key to understanding and working with many geometric figures, including polygons and shapes that relying on parallel sides. So, the next time you see two lines cut by a transversal, remember the power of these theorems and how they can help you in geometry.